Section 5.6 Logarithmic and Exponential Equations. We're going to learn in this section how to solve log and exponential equations using the properties of logs and the properties of exponents. So the main thing we need to recall is the definition of log. Definition of log says y equals log a base b is equivalent to, say, b to the y is a, b to the y is a, provided a must be bigger than 0, b bigger than 0, it can't be 1. So if we are asked to solve such equation, what makes it difficult here is having the log. When you transfer a form from the left side to the right side, it makes it much easier to solve because that drops the log function. So here I can apply 2 to the third power equals 2 to the third equals x plus 5. So x plus 5 is 8. Subtract 5 on both sides, you get x equals 3. Also, another thing we apply here, if we have log u base a equal log v base a, if the bases match, then u equals v. So if I want to solve this, both have the same base 10. So all I have to do is set 7x minus 1 equals 3x plus 7. But before I show you this, one thing you have to keep in mind, that any answer we get for x, it cannot make this quantity here or this negative or 0. Has to be bigger than 0. So if I set them equal to each other and solve this simple linear equation, I get x equals 2. If I substitute that back in the left side, you get log 7 times 2, 14 minus 1. Is that going to give us the same as 3 by 4, 2, 6 plus 7 without getting any negative or 0 values? Let's see, log 13. Yes, this works out. So this is fine. How about something like this? Can I set x equals 64? No, because there's a number in the front. First thing I do, I use the property we covered in the previous section to bring the 2 up on the top of x first. Then I can set x squared equals 64. So x is plus or minus 8. But again, you can't have x cannot be negative in this case. X must be bigger than 0. So the only answer that works here is x equals 8. How about something like this? Can I set x plus 3 equals x minus 1? No. We have to do something with this one. Many ways are there available to work with this one. The tricky part here about it, what we can do is rewrite it as log 5 base 5. Because log 5 base 5 is 1. Log 5 base 5. So then, what we can do on the right side, keep the left hand side the same. The right side I can do log 5 divided by x minus 1. X minus 1. Now it's ready to set both sides equal to each other. So we can set x plus 3 equals 5 over x minus 1. And then we can do cross multiplication. Multiply x plus 3 times x minus 1 equals 5. So we distribute everything up, subtract 5, group like terms. Now we factor this, x plus 4, x minus 2. So that gives me x equals negative 4 or x equals 2. If you go back to the main equation, we can't substitute negative 4 in because that will give me a negative value. So only x equals 2 works. How about this one? Again, several ways to solve such a problem. One way is we may use the properties of logs from previous section. Subtraction becomes division. Now there's no base means base 10. There are two things here you can do. You can use the definition of log, go 10 to the first power equal all of this. Or you can write the 1 as log 10 base 10. So then set the quantity here equals 10. And that will solve it. We'll cross multiply. 2x equals 10 times x minus 3. Distribute the 10 in, subtract 10 on both sides, and divide. And that will give us what we need. And if you test it out, it should work. Next one. That's about exponential function. Exponential function said if a to u equals a to the v, then u equals v. U equals v. So you have 3 to the x plus 2 equals 3 to the 7. So in order for these to be the same, because the bases are the same, the top should equal to each other. So we set x plus 2 equals 7. So for x is 5. Next one, 3 to the x equals 7. Now this one, we cannot get the same base because that one has a base 3 and the other one has a base 7. So you can't set x equals 1. What makes this problem difficult is having a variable on the top. And the only way to solve this is we need to bring that x down. And how do we bring that x down? Is that we need to use the powerful property of log that allows us to bring exponents down. So we can do log both sides, and the best thing to do is you can keep it like this, or you can do log both sides, but you choose the base you like. I'm gonna choose base 3 to match with this 3 here. Then you can bring this x down. Log 3 base 3, it's 1, it's gonna be gone, and then that will leave log 7 base 3 as an answer. So x equals log 7 base 3. That's one way. Or you can just keep it like this as base 10, bring the x down, and then divide both sides by log 7 over log 3, which can be rewritten as log 7 base 3, backwards of change of base formula. So here I showed you exactly what I did earlier. That's the same method. Now another example, you may pause the video and try this on your own. 2 times, not 2 times 5 to the x equals 11. Should we do log both sides? You can, but it would be easier to do what first? To divide both sides by 2. So you get 5 to the x is 11 halves. Then we do log both sides base 5. Log both sides base 5. So then what do we get for this? Bring the x down. Log 11 halves base 5. Next one, solve this. This is more difficult because I have x's, x's on both sides. Now to bring the whole exponent down, we need to do log both sides. But when we're doing log both sides, you can choose any base because the 2 different bases, I would just leave it as base 10. So I just do log both sides. And this will allow me to bring both the exponents, this one down and the other one down. So I'm gonna bring both down with the parentheses around it. Then to solve for x, we need to get the x terms on one side. And in order for us to do so, we distribute the 2x by log 3 minus 1 times log 3 equals x log 2 plus 3 log 2. Then we subtract x log 2 on both sides and add log 3 on both sides. And to finish this up, we need to factor x out among these 2 terms. Factor x out. Then divide both sides by this left-hand side. So you can leave the answer like this, or you can put on the calculator and get the answer. Another example, e to the x plus 3 equals pi to the x. E is just the 2.7 number, and pi is the 3.14. It's kind of like any other number. Again, we're going to do the same thing, log both sides base 10. Bring the exponents down, the x plus 3 and x. Make sure to wrap it with the parentheses. Natural log of e is 1, so that's gone. Then to solve for x, we need to move the terms with x on one side and keep the other numbers on the other side. So we may subtract x on both sides, then factor x on both sides, then divide, and that will give me what I need. Another example. Here we cannot do log both sides because we have 3 terms. This kind of equations has its own way of solving it. We can first rewrite the first one as 3x all square. And then it shows us that there's 3 to the x, which both can be replaced with any letter, let's say u. So that will give us u square plus u minus 2 equals u. Then factor that one out, u plus 2, u minus 1 equals to 0. And that would give me u equals negative 2 and u equals 1. But u is 3 to the x. 3 to the x equals -2, and 3 to the x is 1. But 3 to the x, if you remember the graph of it, it's always going to go up this way. It will never reach negative. So it will never be negative. So 3 to the x is always positive, no matter what x is. So the first equation cannot be solved. The second equation, we can do log both sides, base 3. So then on the left side, I got just x, and log 1 is 0. So x equals 0 is the only solution to this equation.